class. So we're going to continue on in Unit 3, and I thought I'd start off with some smooth jazz there to sort of smooth our way and smooth the edges that are kind of rough in this section. So we're going to come to two more formulas in this case. The first one that we're going to be talking about is graphing using point-slope form. So graphing using point-slope form, there's two things that you need in order to graph. Well, what might they be? Whoa. Point slope form? No way, right? Okay, so here we go. We have our slope, and our point is actually this x1 and y1. And something to take note here is it says x minus x1. So if I have like this first equation down here, I'll show you how to graph it in a second, but to derive the point from this, y minus 4, our point, we take the opposite, right? So our x coordinate is going to be 1, our y coordinate is going to be 4 in this case. Okay, so just remember that you're going to take the opposite sign of whatever it has. Okay, so find the point first. So we're going to find x1 comma y1, and then we're going to use the slope, which is, again, our m, or our rise over run. And just like in 2 sections ago when we talked about how to find slope from an equation, we're going to have to use that here. But again, it's just beside the parentheses, so it's not too challenging here. So we're going to identify the slope. We found the point, we're going to use it. So we come to 1, 1, 2, 3, 4. We plot the first point. Then we use our slope, up 2 over 1. I'm just going to back up and create my line. Ta-da! Boom. Done. Okay, so graphing these point-slope forms, not too challenging. We just have to look at what the slope is and then figure out the point. And I think the point is the hardest part of this whole thing. So if we take a look here at the second one, we have m equals the 1/2, and our point, remember, we take the opposite. So instead of 2, we take -2. It's 1 beside the x. And then instead of a 1, we have to take a -1. So we're going to find this on the graph, we're going to plot it, and then we're going to graph it out. So I'm going to do this last one, and I'm going to have you do the last one on your own. A little tricky. Try and figure it out. Okay, but we graph this as -2, -1, plot the point and use the slope of -1/2. So down 1 over 2, down 1 over 2. Let's back it up here, and we have our line. Okay, so go ahead. If you want to pause the video right now, I'm going to resume number 6 in about 15.3 seconds. So just make sure that you're working on this problem. Good luck, and here's some more smooth jazz. Alright, so you can go ahead and review that last problem. This is number 6. Again, if we don't have anything next to the y, technically this is y minus 0. So we can just plug that 0 in for our y value over here. Cool, so that's point slope form. Any questions? Oh, if you have some, send me an email or do something, because this is video. I can't talk back to you, sorry. Okay, so we're going to move on. This is the last section, or last part of section 2, I should say. Standard form. This is the fun one, because this is the one that almost everybody forgets. This is the one where we have to use a special formula to figure out the slope, and we might have to transfer into a different form or two. Okay, so first, find the point on a line, the x-intercept or the y-intercept, or, whoa, both. X-intercept, it intercepts the x-axis, so that's where it crosses the x-axis. Y-intercept, where it crosses the y-axis, right? So for x-intercept, to find it, we're going to substitute 0 for y. It's the opposite. Because right here is our 0 for y. That means that it's going to be somewhere across the x-axis, and that's what we want. For the y-intercept, we substitute 0 in for x, good. And because we're across this y-axis, x is always 0. Good. Second, if needed, use the slope to locate other points on the line. So slope is, again, rise over run. Or in this case, I'm going to show you is opposite A over B. Opposite A over B. So if we look at our formula, A is the first coefficient beside x, B is the second coefficient next to y. So here's an example. Let me scroll down a little bit here so we can see the whole thing. Example here is 2x minus 3y equals 6. Let's go ahead and find the x and y intercept and the slope just to have some practice. So we have the x-intercept. We plug in 0 for y. If I plug in 0 for y, this whole thing's 0. 2x minus 3y is 0. So we have 2x equals 6. We divide by 2, x equals 3. So our x-intercept is 3, 0, just like up here. So we come here to 3, 0, plot our point. Now let's find the y-intercept. So let me forget about throwing a 0 in for y. Let's go ahead and throw a 0 in for x in this case. 0 minus 3y is just negative 3y equals 6. Divide by negative 3, divide by negative 3, y equals negative 2, and we have 0, negative 2 as our y int. This is our x int, and we have our y int. Okay, so let's go ahead and graph this. This is one way. If you can find both intercepts and it's not a fraction, then by all means go for it, because it's easy. We connect the dots. 0, negative. Okay, so we found the x-intercept, we found the y-intercept. We're going to go ahead and connect the dots. So this is pretty simple. If you can find both and it's not a fraction. To check for the slope, just so we can sort of review it, m is equal to opposite a over b. Opposite a in this case is going to be negative 2. So m equals negative 2 over b, which is negative 3. This simplifies to m equals 2/3. So let's check it. If I go up 2 and then over 3, do I hit my next point? Yes, I do. And you can use that to find the next point in the line if you have to. And likewise, down here. So you really only need one point to start, just like in point slope form. But if you can have two, if you can have the x and the y-intercept, it's pretty easy to connect the dots. So go ahead and try 8 and 9 on your own. And in about 20 seconds or so, I'm going to reveal the answers. So if you need to pause for some more time, go for it. Again, here is some smooth jazz. Okay, so just wrapping some things up. We have number 8. We found the x-intercept and y-intercept to be specific points. So we can actually use those 2 points to plot them on the graph and then connect the dots. Unfortunately, in 9, what happens with this y-intercept? We have a negative 1/2. Now, yes, you could guess and estimate where it's going to fall on the y-axis, but we really want specifics. We really want it to be true all the time. So we don't want to just guess. So to do this, we have to sort of nix the y-intercept. We start with the x, which is right here, and we use our slope of up 1 over 4. And you can see where it does cross roughly halfway, right? So we want to be exact, so we want to choose 2 points that are perfect to connect the dots. So again, this has been 3-2. This wraps things up for that section. This is Mr. Korb. Hopefully this has been helpful, and I will see you in the next video.